Hey, what's up guys, my name is Cherno and today we are going to be talking about events, and we're going to actually write a quick project which includes an event dispatcher and an event system to basically play around with this and see how it works. So first of all, what is an event? An event is, it can be many things, okay? It's essentially just something that happens throughout our game or our application that we want to actually report to various different entities. Okay, so for example, if the user clicks the mouse on something, we usually want to be like, hey, everyone who is subscribed to this kind of event system, the user just clicked on a mouse, or the user just clicked his mouse or her mouse on a certain object, or something like that, yeah? Usually you would kind of provide data such as which mouse button was pressed, the location of the click, all of that kind of stuff. And then the entity that is subscribed to that event system and to that particular event, a mouse press event, for example, they would receive all that data. And they'll also get notified, hey, this happened, right? And the upside to this is that you don't actually need to check, right? So instead of kind of doing polling, we're pretty much doing interrupting. So what I mean by that is, previously, or I guess any other way to do it would be, for example, to, in your entity's update method, be like, hey, if the mouse is pressed, right, and the button is left, then I want to do this, okay? That is basically you querying the mouse. So you're like, hey, mouse, where you at, right? What we're going to be doing is kind of the other way around. So whenever the mouse does get pressed, we actually tell the entity, hey, the mouse got pressed. And then the entity can do whatever he or she wants, right? So the idea is that this is also very, very useful, not just for kind of, I guess, cleaning everything up and making it look a bit nicer, as well as not having to continually query what's actually happening with the system, right? You actually get notified instead. Apart from that stuff, it's also very important for concepts like layers, because what happens is that if you have two layers, and you can just picture them as layers in Photoshop or something, if you have two layers on top of each other, and you only want, you obviously want to handle events for the one that's on top first, and then halfway through you might not want to continue, right? So for example, if I have a box on top of another box, right? If I have a panel on top of another panel, and I want to maybe implement some kind of functionality where when you click and drag, it moves the panel that your mouse is on, right? How do I figure out which panel I'm actually moving? So this is probably a bit of a terrible example, but no, sorry, it's a very good example. I just can't explain it very well. Let's say you've got a panel. You've got this red panel. Excuse me. You've got this red panel, and then you've got this, okay, apparently it's an ellipse, but anyway, you've got this and this, right? When you put your mouse over the blue ellipse, right, you want to maybe click and drag and it will just move the blue ellipse. However, when you put your mouse over this red thing, for example, you might want to move that. So basically what I'm saying is, how do we handle that, right? How do we say that that if these are on separate layers and I move the front layer, how do I do that without affecting the back layer, right? Because what you could do is you could do like a bit of a raycast and figure out where the mouse is over which, and now it's really messy right now, yeah? We don't want to do that, okay? Instead, we have them on separate layers. The blue ellipse is on the layer in front of the red rectangle, right? And all that happens is once you handle a mouse click event, if it is inside the bounds, you kind of tell the event dispatcher, hey, I've handled the mouse press event. Do not propagate it to the rest of the layers. Okay? Anyway, there's a huge speech I could give you guys about events and whatnot, but we're not going to do that. We're just going to kind of implement a system. Now, unfortunately, I am starting from scratch, so this video might be a bit longer than I would have hoped it to be, but I'm going to try and rush through most of the kind of boilerplate code. Okay, but essentially we're actually going to start with events. We're going to kind of start with events, and then we'll kind of create like a little sandbox to play around with. So I'll make a new class. I'll just pop this into like events, and I'll call it event. Okay, so this is going to represent all of our events. This is going to be a base class that you will essentially have to extend, right? So if you wanted to, you could make it abstract. We're not actually going to add any abstract methods into this, but you can make it abstract just so people can't instantiate it. Kind of the same way as if you made the constructor private, I guess. So first of all, we'll let everyone create an event who extends from this class, right? And then we'll usually take in some kind of event type which we need to create. This will just be an enum. Now this is actually one of those things that would have been much easier to demonstrate in C# rather than Java, just because that language supports a lot more things than Java, but I'm going to try my best. So we'll handle 3 events here: pressed, released, and moved. So if you guys are okay with this, I might actually do future videos in C# demonstrating stuff like this, because it's a lot better. But regardless, okay. So we've got a basic kind of system going on here. All I'm going to do apart from this is just be able to basically see what type an event is. So I'll have a get type, which just returns type. That's it. That's actually all I'm going to add into this event class. That's it. Okay. So we have 3 event types that we've explicitly stated, and as we add more, we have to add them to this list, to this enum. We've let every subclass create a new event, right? So only a subclass can run this constructor, okay? Which actually might not work at all because it's abstract. Anyway, I don't even know, man. Yeah, that actually won't work. Let's instead make a... That's actually totally fine, by the way, because I forgot that we were overriding a constructor, so that's okay. Anyway, we've let every subclass instantiate event by calling it constructor, and then we finally got a public get type so that anyone can see what an event is. So for example, right, I'll make like a mouse move event, for example. So we'll make a new folder called types, okay, and then in types I'll make like a mouse moved event. So this will extend event. We'll go ahead and implement we'll import it first of all, and then we'll implement the constructor. Okay, so when we move the mouse, we usually want about, let's just say 3 parameters. We want the X, the Y of where the mouse currently is, and we might also take in whether or not it was dragged when it was moved. Okay, so pretty simple here. I'll make all this stuff public. We've got X, Y, and dragged. You probably shouldn't make it public just because, yeah, let's not make it public. Because obviously we don't want to be able to change this, but I'm actually going to, for the first time ever, use Eclipse's generate getters and setters thing. Select getters, I guess. Yay, easy. Okay, so the type is going to be type dot or event dot type dot. Okay, sure, just don't tell me. I got this, mouse moved. All right. Did I not make that? No. I meant to make that public. Okay, cool. There we go. So this is an example event. Okay? What happens is when you instantiate this, you give it the right data. This should be public, by the way. You give it the correct data. And then it sets the data, right? And then anyone who has access to it, to an instance of this, essentially gets to see all this information. Okay? And that's pretty much it. Alright? And that should be a boolean. So there we go. We're done with this class. So that's an example event for you guys, alright? Since we're here, we might as well kind of make the rest of the events. So I'm just going to make, actually make a kind of intermediate event called a mouse button event, which will extend event, because button events, like the release and press events are very, very similar, okay? So we'll have something like a button, like the button key code. The button code, and then we'll have the location of the press, right? And then we'll actually make this protected as well. And then all this will take in is the button, the X, the Y, and since this is going to be a subclass, we'll also take in a type of event. And then we'll call super with the type, and then we'll set the rest of the stuff up. This dot X equals X, this dot Y equals Y. All right. Brilliant. So there we go. I'll generate some getters, and yeah, we're making these protected because they will be changed, possibly. They actually probably won't be. We could have made them private, but it's okay because we might want them. So, getters. Done. Alright, awesome. So there we go. That's our mouse button event. Now, we have two more. We have a pressed event, which of course now is going to be basically no code at all because it will simply extend a mouse button event. That's actually all we have to do, except instead of type, we're going to manually set the type to be event.type.mouse pressed. We'll import that, okay? And then we're going to do the exact same thing for mouse released. Obviously, if this wasn't Java, we would put all these classes into one file, but hey, you can't do that in Java because, you know, who would want to do that? Alright, so here we go. I don't know why that happened. I did not mean to do that. Alright. Released. So you can see how simple this is. These classes are actually exactly the same. The only difference is the event type, okay? Because I've made this kind of intermediate class which extends event, which handles pretty much everything, and then we just put the type in here, okay? Because release and press events are basically the same. They're just kind of, you know, whether or not it was released or pressed. So there we go. That's our event system. That's actually pretty much all we need in terms of events, okay? Now we can get on to the meaty stuff, and the meaty stuff is essentially the event dispatcher system, okay? But that is the event system. So it's pretty simple. All it is classes which represent certain events taking place, okay? And they have a type, and that's it. That's kind of my summary. All right, so let's make a class that is essentially the event dispatcher. So what's going to happen is we'll also make an interface called event listener, okay? And what this means, what an event listener is anyone who wants to subscribe to events, so anyone who wants to be notified of events taking place, okay, needs to basically implement the event listener interface. So in the event listener interface, we have a public boolean on event, okay, and it takes in an event as a parameter, okay, and that's it. So the reason it's a boolean is because we're actually going to be able to return true or false based on whether or not we want further, event subscribers to actually process that event. So I'll show you guys how that works a bit later on. So what happens in the event dispatcher is we set one of these up every time we get an event, okay? And the event dispatcher it basically does exactly what it says, right? It's a dispatcher. So what it does is it dispatches the event into the appropriate handler based on its type. That's it. So it's basically a really easy way for us to be like, hey, I want to handle mouse events with this method. I want to handle key press events with this method. And then the dispatcher's like, okay, cool. So whenever I get events, I'll tell you where to go. So public event dispatcher event. So this sort of event equals event. And then we'll have a public void dispatch. Okay, which will basically take in an event type and an event. So listener, and we'll actually make one more. We'll make one more class here. Actually, maybe we should make it an interface. Yeah, I think we should. So event handler. This is actually going to be pretty much the same as, I almost don't want to make this because it's going to be kind of the same thing as the listener except a void. Event, I'll call it event handler. It doesn't actually matter what it's going to be called really. And then there we go. Okay, public void event handler. That's just what it's got. That's basically the method it's going to dispatch it to. Now, we don't even have to actually ever instantiate it because we're using Java 8, so I'm just going to use lambdas for all of this. Just something to keep in mind. So anyway, with this, basically the first thing we have to do is check to see if the event has been handled already. That's where that boolean comes in. That's an event listener. If this returns true, that means the event has been handled. Okay, if the event has been handled, okay, did I put that into event? No, I didn't. So we need to have a boolean that's essentially handled. Okay, so every event has a boolean, right, which states whether or not it's been handled or not. Okay, now I've set this to be not private or public. Okay, if you do not set a visibility modifier, it essentially means it's going to be only visible to this package, because I do want event handler to access this and write to it. So I want read write access, but I don't want anything else to do it. So anything in main, which is like the not the event API, right? This is our sandbox. That shouldn't be able to see handled. It might want to see what handled is, but it definitely shouldn't be modifying it. Okay, so setting it to kind of neutral or default is the pro strategy. So if event.handled will return, so we're not going to handle anything if it's returned. Otherwise, this is where the types come in, right? If the event type actually equals the type that we're trying to handle with this dispatch, then we simply, we essentially will have to set event handle, but we also, the main thing we're doing is, sorry, this should be event handler, and I'll call it handler. We'll basically just run the, what was it? Event handler. Event. I might, like, honestly, I'm going to change this to on event, because it kind of is a bit weird. Okay, cool. So there we go. So basically, interface event handler has on event, and also you can see listener has on event as well. But the only difference is one returns a boolean, the other one returns a void, essentially. Okay, there's no real difference. It's good to have two interfaces though, just because they do mean different things. An event handler is very different from a listener. Okay, so there we go. Right, and then this. Oh, sorry, my bad. This should totally return a boolean. They are actually exactly the same, to be honest. So, you know what we'll do? We will actually combine them. Because if they're exactly the same, if you were really cool and you were really kind of a, I don't know, an object-oriented programmer or something, you might create two events with different names that do exactly the same thing. I'm not going to do that though, so it's cool. Okay, so, there we go. The actual difference, right, is the fact that an event listener should really return void, because we're never going to query it. Okay, so I am actually going to kind of undo what I did, and give me a break, guys. It's like 8 a.m. And we'll create another one called event listener. Okay, which actually is the same as this, but it returns void. Because there's no need for us to return anything from an event, so void, and this should be an interface. There's no need for us to return anything from an event listener, because that doesn't matter. That's not actually the event. There we go, done. So that's the event system pretty much done. That's actually all you need to implement this. Okay, I could stop the video here, but obviously I haven't shown you how this works. But what I mean is we're basically done. Okay, so how do we create events? How do we generate this stuff? So what I'll do quickly is I'll actually set up a window class. Okay, we'll put it in the core package here. This will basically extend JFrame. Okay, I'm going to kind of rush through this really quickly because this is not what the video is about. So we'll set the title to name. Let's import JFrame. We'll have to set up some kind of screen in a minute, but set default close operation JFrame.exit on close. We'll center the window. And we'll set visible to true. Okay, so what happens is we're going to quickly make a canvas so that we can actually draw some graphics on the screen. I'll call the canvas screen. Okay, so screen is just our graphics kind of drawing thing. We'll extend canvas. Alright, I'll just add a suppress warnings for this. So we'll have a buffer strategy, we'll have a graphics object. When we create the screen, we will take a size for it. We don't really need a size for it. We do need a size for it for clearing, but to be honest, that'll be kind of set. So we will set a size for it over here. We'll have an init, which just creates a buffer strategy so that we can actually double buffer this or triple buffer it. Doesn't really matter. If we have a single buffer, we'll see flickering. Begin rendering. Okay, that'll just basically begin everything. So it'll set our parameters here. So we'll get the buffer strategy, and we will set g to bbs.getDrawGraphics. Okay, let's import all this stuff. A lot of code here, and I am rushing through it. Okay, so clear. So we'll just clear this to white again. And I'm not making like some kind of API here, so I'm not going to take in parameters for everything here. This is just to demonstrate this. 0, 0, get width, get height. We'll have a public void end rendering, which just basically disposes everything. That's kind of like a flush. That's pretty much it. There should also be get graphics object, which will return G. Okay, there we go. Basic screen. So we'll add the screen, which we haven't made yet. We'll make it right here. And we'll pack the frame so that it basically will adjust the size of the frame to match the screen, or to fit the screen. And that is pretty much it as far as the screen goes. So we've got a rendering surface now, that's great. We'll add the, so we'll init it, and I'll call this run method. So the way we can run pretty well in Swing, because we do want to obviously process events as well, it's pretty simple. What we do is we essentially want a while true loop, but instead of that we're kind of going to write a semi-recursive function. So we'll clear the screen, we'll begin rendering, we'll clear the screen. We'll probably run the onRender method, which we haven't actually written yet, with the graphics object, get graphics object. So we'll have a private void onRender. So this will basically call graphics. This will basically call all of our layers render methods, and then we'll end rendering. Okay, now just for fun, we'll sleep for about 3 milliseconds just so we're not using too much. We'll have to cache some crap for that. Okay, and then finally we need to keep rendering. So the best way to do this is just to invoke use the invoke later. So invoke later, basically our goal is just to do that, right? So we keep rendering. But the problem is this isn't on a separate thread. If we did have it on a separate thread, we might run into problems with a few things because we're multi-threading Swing, and that's not a good strategy usually. So what we can do instead is we can still run it on a single thread, but use Swing utilities invoke later. What that will do is just invoke this stuff, and we could just use Lambda for this. It'll invoke this stuff after it's processed all the events and whatnot. So basically our window will still be responsive and everything, it won't do this straight away, right? If we keep running this code, the window is never going to get a chance to process events such as mouse clicks or whether or not it was closed, or do all its other internal stuff, right? Because it'll be blocked. So that's a really important thing to do. Now, we've got this rendering thing now. We basically just need an onEvent thing, which is actually what's going to do our event stuff. And finally, we also need, actually that's pretty much it. I don't think we need anything else. I mean, we have to talk about layers in a minute, but I think that's about it. Yeah, cool. So that wasn't too difficult. Layers. What are layers? So layers, I'll make a class called layer, pop it into the layers package. Layers are just layers of graphics, essentially. So we'll implement event listener, which means that we need to have the on event. Notice this is the one that returns void. Okay, we can kind of implement it here without actually doing much, but we'll have an on update, which we might not use. I'm only adding this stuff just so that it kind of maybe makes more sense for you guys. Then we'll have an on render with our renderer, which is just a graphics object. That's all a layer needs. Okay, so I'll make an example layer out here in our sandbox, so that's not part of the API obviously, which extends layer. Import that, and then we'll actually talk about everything pretty much there, okay, as far as all of that stuff goes. So let's talk about how now that we've got layers and whatnot, we need to essentially add a layer stack to our window. So this layer stack is just going to be a list. So we'll call it, so we'll call it layer stack. It's just going to be an array list though. Stacks in Java are a bit weird. And in fact, we really don't need to use a stack for this. A list is actually what we want. So what we do is when we added it, we can add layers, right? And just for debugging and whatnot, I will print out the name of it. And by name, I just mean like hash basically, so we can see which object it is, which instance it is. Okay, and then on event. Now here's the difference. This is a nice little difference, and this video is kind of turning into more of a layer window, but sorry, a layer video. But hopefully we won't do too much on that. Maybe I should have made a layer video first. But basically, what we want, but layers and events kind of go hand in hand. That's why I'm not talking about. So basically, we process our rendering normally. Yeah. So we kind of do that normally, and all we really do is we call the for each of these layers, we're calling layer stack I dot on render. Don't know why Eclipse isn't helping me out here. All right. Forgot about Java and its lack of overloaded operators. So there we go. It calls on render for each of these layers, and you can see it just does it in order. However, on event kind of does it the other way around. It does it from top to bottom instead of from bottom to top, okay? Because obviously we want to handle events for layers which are closer to us, which are overlapping everything else first. So the way we do that is we can just set this equal to layer.stackSize -1, okay? As long as I is greater than or equal to 0. And then I minus minus. So now it's basically iterating through the list in reverse order, okay? And we'll just call on events with events, okay? So events get raised in the opposite kind of order, okay? So from top to bottom rather than from bottom to top, which is how we render things. So there we go, bit different. Now, as far as our actual events go, the way we can add events is we can obviously just add you know, Java's add mouse listener. Make sure you add this to screen, obviously, not to our window, because the screen is what's rendering on top of the window. We'll just create a new mouse adapter. And the methods I really want are just mouse released, mouse event E, and you can see Java's got a kind of a similar system going to what we do, and a mouse pressed. Okay, so here's what we do. Every time the mouse is released, we call a mouse released event. We create a new mouse released event with the appropriate button, the X and the Y. Okay, and then we just call on event with the event, and that's it. And then that, of course, will dispatch to all the layers. Now, this should be public, and I'm guessing pressed should, yeah, also be public. Okay, so we're doing the same thing for mouse pressed. Okay, that's actually it, done, right? And then finally we'll have one for motion. So add mouse motion listener, new mouse motion listener. yeah, we don't have to use the adapter version because we do actually want both of these methods. Okay, and then similar to what we had here, we kind of create the same thing, except it's going to be a mouse motion or mouse moved event. And all we really want are the location and whether or not it was dragged. Obviously, if it's moved, it was moved, not dragged. However, if it was here, it was dragged. That's the only difference. Okay, there you go, done. So that's all of our event setup. So it now should propagate that to all of our layers. So now let's learn about how we can use the event dispatcher to actually properly handle this stuff using our example layer and whatnot. So over here, we'll just essentially have on event, which overrides our event. Okay, so every time we get an event, it should get sent here, right? So that being said, if we just kind of print out event here, okay, and we add this layer, so let's make some main method stuff. Well, in fact, we can just do the whole thing here. So we'll do window equals new window. We'll call it events. It'll be 960.540. Window.add layer, new example layer. And that's probably all we need, right? Okay, so you can see we're getting a ton of mouse moved events. When I click, we get pressed and released events. You guys can see that in the console. If I don't move the mouse, we don't get mouse moved events, which is good. We don't want to keep sending the same event over and over again. Basically, it seems to be working pretty well. So clicking, as you can see, works. That's pretty awesome. Okay, you can also add other events like focus lost and whatnot, but we'll talk about extending this a bit later because we don't need to talk about that now. So, example layer. What I'll do is, now that we can handle the events, our kind of, what we want to do is we want to dispatch them to different methods based on what event type they are. What we could do is have a massive if statement, or a switch statement, I guess, that's basically like, if event.getType equals event.type.mouseMoved, then call this. But we don't want to have that, right? Because that's very messy. So instead, what we do is we use the event dispatcher. So we have our event dispatcher. We'll call it dispatcher. We set this equal to a new event dispatcher event, right? And then what we do is basically we can create a bunch of methods. Now these have to be in compliance with basically our event handler interface, right? So our event handler. I hate how Eclipse brings their stuff up first. I mean, come on. Clearly I don't want that. Which is a public boolean on event. So basically, let's create a public boolean. We'll call this like on mouse pressed, for example. We have to take in, we can take in a mouse pressed event straight away, actually. Okay. And then if that happens, we'll say mouse pressed e.getButton, for example, just for now, right? And then we'll return false, which means that we're not blocking other layers for now. So basically, the way we use this is pretty simple. We say dispatcher.dispatch event.type. Which one are we trying to dispatch? The pressed. Again, you can actually kind of imply this stuff if you're using C++ or something, but Java's a bit limited, so I'm kind of showing you guys the Java way to do this. And then you basically have to have an event handler which on event calls or returns on mouse pressed. Now this is extremely messy, and I would really hate writing it like this, especially because if you're doing C or C#, you can literally just have a function pointer in there and that's it. Good news is Java now supports lambdas, so what you can do is pretty simple. You can actually just have a lambda. So event e, right, and then we'll just call on mouse pressed. And then we'll have to cast it to a mouse pressed event, which we know it's going to be since the type is mouse pressed. E, and that's it. So you can see how much simpler, how much easier that is than having to have a full interface and anonymous inner class creation thing that we had before. So this is much easier now. Okay, this is the method that we're calling event. It matches these parameters, of course, because of where is it? The event handler. which has an event, and then a boolean, you know, that kind of returns it. That's self-explanatory. And then this is what we're calling, okay, with these parameters. There we go. So we just basically have to do that. And so what happens now is when I press my mouse, you can see it presses. Pretty cool, okay? So now if I add some more, so we'll have a released, and we'll have a moved. I'll basically copy and paste this. We'll have a on mouse released and moved. So when we move, I'll just say something like mouse moved. I'm not going to spend too much time writing this code. So this has to be a mouse moved event. Sorry, mouse released event. And then we'll move them up here. So unfortunately we can't really infer anything here. We have to cast stuff, so it's a bit annoying, but that's okay. And then this will be released, and this will be moved. Okay, so now we're dispatching it into the right functions or methods. So we'll just do something like released plus e.getButton. And remember, we do have stuff like we do have more information here, like where it was released or where it was pressed, right? So I can do something like that, and if I run this, when we move, it says mouse moved. When I press and release it, it says exactly what I printed there. Okay, so it's cool how we kind of get a location as well. And you can put any information you want, yeah? You just have to remember that you have to add it into the appropriate event class, okay, however that may be. And when you're dispatching them from the internal kind of API, you add that information in, and that's it. It's really, really simple, and it's awesome, okay? So, that being said, now that we've got this, let's make something useful, and I'll demonstrate the I will demonstrate the kind of booleans that you can return and how you can use them. Okay, so my plan here is basically I'm going to make 2 layers. I'll give them names. I'll give them a color. I'll have a box that I'll render, and we'll have a static final random. All right. So in the constructor, we'll take in a name for the layer and a color, which we'll set up. Oh, install extensions. How did I get here? Get out. Oh, I can't. Oh, what? Go away. Goodness me, that was terrible. Okay, so color, and then we'll make a box, which is just going to be a new rectangle. So we'll randomize this a little bit. Random.nextInt, maybe like 300 plus 100, and then random.nextInt 200. I'll actually make the window a bit smaller because it's a bit too big. And width and height, 8050 should be okay. I'll quickly make the window a bit smaller, 640, 360, and now we can put the stuff in. So I'll have like the bottom layer, which we had first, which I will make, I don't know, man, we should make it like a blue kind of color. What's a nice blue color? We'll just say new color 2233 CC. That's a nice color. And then we'll just kind of reverse that for the red. And we'll call it top. So red's on top and blue is on the bottom. There we go. We made some example layers now. And then all we want to do here is kind of render it. Okay. So to render it, we just need to override the onRender method. GraphicsG. Okay. We'll set a color. We'll fill the rectangle. So box.x, box.y, box.width, box.height. Alright. And then we'll just draw the label as well, which is the name. So we'll draw it in white. At about box.x plus 5 maybe, and box.y plus 15 maybe. text in Java seems to be measured from the bottom, even though the projection matrix says that the top is top left. So anyway, or 0, 0 is top left. Anyway, that's why there's 15. Okay, so yeah, this should be pretty solid. Now let's see if we get the boxes rendering at least. So we got bottom and top, great. Now let's make these event things actually do something useful. So I'll delete the printfs or the system out of print lines, and we'll get onto it. So basically, when we press the mouse, okay, so we want two variables. We need to know the previous mouse position. We're going to make it so that we can drag the boxes around. That's what I'm doing. Private boolean dragging equals false. So px and py are previous x and previous y. That's just for mouse positions, so we know how much we need to drag, and we can work out deltas and stuff like that. So on mouse pressed, if box.contains a point here, which is going to be e.getx, e.gety, then it means that we've basically started dragging. So we'll set dragging equal to true. So here's the deal. We're actually going to return dragging, okay? Because what that will do is it will mean that if we actually do essentially contain that point, which means that we've clicked on a box and we've started dragging it, we don't want to send the events to layers further down, okay? Otherwise we do. So I'll demonstrate, I'll toggle these things for you guys, and I'll show exactly what's happening. So, you know, it doesn't matter if the mouse is released or not, we'll actually just set dragging equal to false, and we'll just return false. We don't care about blocking release events for every other layer. Now this is the bread and butter of the actual operation. So we'll just bring out these variables real quick so we don't have to keep typing get x and get y all the time. If we're dragging, right, we're going to basically work out the delta, and we'll set box.x equal to x minus px, and box.y equals y minus py. Alright, so working out the deltas. And then finally we'll set px equal to x and py equal to y. So that's it. We're kind of updating our previous's and then obviously figuring out the amount that it's changed here. So we'll usually get something between, you know, I don't know what we'll get, but it'll be between like -30 and 30, for example. It depends how fast you move your mouse. So there we go. Awesome. This should work. And then we'll return dragging. So, that being said, if we now open this up, we should be able to drag these boxes around, or not. So it appears I've done something wrong. Yep, I did equals instead of plus equals. It was already setting it to the delta. Now you can see we can drag these around. Okay, I'm just clicking on them and I'm dragging them around. Alright. Pretty cool stuff. So, what will happen, I shouldn't have done that. Let's put them back here. Okay, so what will happen now is the top is obviously always going to be on top. Okay, now what that means is if I'm on top and I click on the top layer, even though it's kind of over the bottom layer, it's going to move the top layer, not the bottom layer. However, if I click on the bottom layer, it's going to move that. Okay, that's because of the event system, right? You can see I can't really move the bottom layer unless I'm actually clicking on it. Now, if we didn't do that, yeah, if we didn't return, let's say we return false, what that would mean is that if these two layers were on top of each other, that should probably be moving both of them. Oh, well, it's because we're also returning dragging here. So let's return false. Okay, so now you can see they both move. Alright? That's because we don't care if it's on top of what, we're kind of propagating the events like that. So that's one thing you can do. However, if I also always had true on mouse press, for example, then that means that I will never be able to move that bottom layer. Yeah? You can see I'm trying, I can't. Because the top layer is always eating up all the events. Okay? So you can do some pretty cool stuff with that. So they both should be dragging, and that's the functionality we want. So you can see we now have the ability to block events from different layers depending on anything really. But that basically just reinforces the fact that that's how the event system works. Okay, so that's pretty much it, guys. I hope you enjoyed the video. If you have any questions about events or anything, just leave them in the comments below. I'll try and reply to as many comments as I can. We will be integrating this into the game programming series next video for the game programming series. Okay, so next episode of that we will integrate this event system into there. But that's pretty much it. I just wanted to make a standalone video so that everyone could watch it, regardless isn't a word, regardless of whether or not you guys are essentially up to date with the game programming series or not. So there we go, events, pretty cool. This entire code will be on GitHub. There'll be a link in the description of this video to this code so that you can play around with it yourself. And again, any questions, pop them below, and I hope you guys enjoyed this video. Thanks for watching. Hit the like button if you enjoyed it, and I will see you guys next time. Goodbye.